Okay, this is chapter 22, number 18. We're doing a mean problem. This will be a confidence interval for means. We know that because the problem gives us a standard deviation and says the word average or mean in it. Okay, pause the video and read this paragraph. Hopefully you've done that. First thing we have to do every single time is identify our variable. Remember, this is a mean problem, so we don't have success or failure. There are no proportions. Our main variable is mu, so we write let mu represent the mean daily fees collected at this garage, technically just weekdays. We're supposed to check our conditions. We have to just assume that they did a good sample here. If this sample of 44 weekdays doesn't represent the whole year, if that were during the holiday season or something, maybe this might not be a good sample. So let's just assume they did a good sample. We need our samples to be independent. If we go out and collect a bunch of different samples, the act of collecting one sample should not affect another. Our nearly normal condition is that the population should be something like a normal distribution. It should be roughly symmetric, meaning we expect half the time for the numbers to be high, half to be low, and so forth. As n gets bigger, that becomes less of a concern. Here, our sample size is 44, so we should be okay there. And we need n to be less than 10% of the population size. Okay, we write down our sample statistics. Remember, our goal here is to make predictions about the entire population based on one single sample. Our sample average was $126. Our sample standard deviation was $15, and our sample size was 44. Okay, the calculator will do all of this for us now. We're going to, every single problem when we're dealing with means here will be stat and under tests, and we'll only use 2, 4, 8, and 0. If the button says prop on it, you're going to have a bad time. It's the wrong button. So we have 2 and 4 for our hypothesis testing, and 8 and 0 will do our intervals. 0 was when we have two different samples that we want to compare. Here we only have one sample. We only have one sample size. We only have one standard deviation. We want button 8. Sometimes we'll know the actual data. Sometimes somebody will give us all 44 pieces of data that we will type into L1. Here, though, we don't know that. We only know the sample statistics. So we'll highlight stats, and we'll type in what we know. We know X bar is 126, S, our sample standard deviation, is 15, and our sample size is 44. We were doing a 90% confidence interval. We hit calculate, and there's our interval. And we just write that down. And then the hard part is interpreting this. Remember, we're making predictions about mu based on the sample. So we're 90% confident that this, the mean daily fees, will be between these two numbers in dollars. Don't forget your dollar sign. Like always, when we say 90% confident, what that means is 90% of all possible samples we could collect of this size would give us a confidence interval that contains the thing we're after. And then this consultant makes a claim that the daily amount collected here should average $130 per day. Not according to our interval. We maxed out at 129.8. And you might think, well, that's close to 130. This isn't horseshoes. We don't care. 130 is not in the interval. We don't believe it. In fact, we are more than 90% confident that guy is wrong.